going to talk about the next phase of AI in software development. I'm sure that all of us have seen the chatbots, use them as our assistants. They are really impressive. Sometimes they are magical, but they also suffer from being chaotic. And if you have ever tried to build some serious enterprise system, you know the pain and you know what I'm talking about. And today we are going to have a look to explore a new approach that will shift from what we have some simple chatting with code to what we'll call orchestrating it. We look at this new architecture designed not just to assist you, but to provide you some reproducible, reliable code generation workflows. And we call this approach JAIG. And I'm very happy to introduce my colleague and friend Vladimir Sonkin. We have been working together for more than 11 years. It's been an excellent period in my professional life, and I couldn't imagine better when we started working together. A few things about Vladimir you see here on this slide. His journey with neural networks actually started back in 1999. This is the previous millennium. Of course, we are long before the current hype cycle. He was an enterprise Java developer for more than 20 years, and now the AI is raising. Since 2022. I can tell you that he has become more and more obsessed, or I say interested, about generating code using LLMs. Not just for toy examples, but little by little, this interest led to the creation of JAIG, what we are going to tell you. JAIG is the acronym from Justified AI Power Generator. And together we have even published a scientific research on this, an article that can be found online. I'm Cătălin Tudose. I'm a Java champion since February 2024, so this means almost 2 years now. I'm working in the field for more than 25 years now. I have conducted now more than 6,000 hours of trainings, because this is our current work, mine and Vladimir. We are teaching others based on our previous experience. We've been software developers for years, and we made this step to teaching others. I'm also the author of JUnit in Action and Java Persistence with Spring Data and Hibernate. You can find these books at the Manning publisher. So together with Vladimir, we'll look at the current state of AI coding tools, and that we realize that something is missing. We have many advantages. We have the speed, we have the intelligence, but we lack some control, and this is what we are going to focus now. We already have some good tools. Probably you are already familiar with GitHub Copilot, with Cursor. GitHub Copilot is an AI-powered coding assistant. It helps you writing code. It suggests great completions. You can even generate full methods, full classes, but almost it remains somehow at this level. Cursor, it goes further. It is designed to work together with an LLM. It integrates with LLM not just to autocomplete, but it will have some introspection into your code base. So it will talk to your code base. Your code base will serve as its repository, and it will help you generating code faster, based also on what it has as input from the code base. These tools are relying on agents. Agents exist from the beginning of the AI as a concept, but what we have to say is that they are somehow chaotic. They generate the code, but they are not deterministic. Every time when they generate the code, we don't know anything about the exact steps. And if you generate the code several times, you may have some different ways of generating the code. So if you look here at the left-hand side of this picture, you may think, okay, the agent knows a few things, it plans some changes, it has step A, B, C now, but maybe next time it will have some C prime, then B prime, then A prime. So this means no determinism. And now if we look at the right-hand side, we try to shift our approach to orchestration. JAIG will make things in a more organized way. We define some exact steps, some validation. JAIG allows us to implement the code generation that will be completely automatic. Yes, we try to move ourselves from just the non-deterministic agents. And yes, they are creative, they are nice, but for enterprise application, it is very important that you work in a predictable world. And we introduced this idea of architectural drift. Architectural drift. Maybe you've heard about continental drift, when the theory says that all continents were together at some time and they started to move apart until we have the actual geography. And now to think at real life architecture, to explain the architectural drift, you have a nice house. It was built according to some original architecture. Everything is nice, it follows some rules, but you receive some request, do new things. Add a new room, add a small extension, add an antenna. This is like in software development. Your code base is not frozen, but you receive new things to develop. And if you don't follow the original approach, then the original architecture, then you are going to face a drift. This drift happens because of several reasons. We may be honest to say that us as developers, we are lazy. We try to make patches to solve immediate problems. You may be under some high pressure, because if you work in software development, and I'm sure that you have worked, you know, you have pressure, you have to solve this sometimes until yesterday. So you drift from the original architecture and you focus on what you have to do right now. And LLMs are also acting as lazy developers or developers under high pressure. They are excellent at local tasks to fix some function, fix some bug, write something brief here, but they lack some holistic vision of the project. And on the long term, this will accumulate, this will diverge or will drift from the original architecture, and it will bring you problems. The beautiful software architecture that you have will turn into some house that you see here at the bottom right. It is no more so easily sustainable or maintainable. And this is some central conflict. On one side, we have the AI agents that offer creativity and flexibility. They are our great assistants. But on the other side, we have the orchestration, the JAIG approach that we are trying to introduce now. So if you look at the left-hand side, the picture, this is like an assembly line. It offers full automation, reproducibility, and predictability. Not only that the agent assists you, but you would like to follow some plan to move from being assisted to having a system that executes some reliable workflow.
So if we want to, can I add something for the previous slide? So if we want to completely move into fully automatic workflows, yes, when we don't have human in the loop, when we don't just use LLM as assistant, but we want to automate some workflow completely, then we need predictability, we need reliability, and this is our purpose, and we need to get rid of architectural drift.
Absolutely. And let's say that we have some extremes. On one side, the vibe coding, and on the other side, this deterministic workflow that we try to introduce. Of course, there is some space between these two ones, but we would like to focus on the reliable workflow. So we have this central problem. You may keep on adding and adding your new features. This is how software evolves. Yeah. But if you forget about the architecture, if you allow the architectural drift, you will get more and more technical debt. You may have heard about this technical debt, at least from the refactoring. If you forget about refactoring while you are doing coding, then you accumulate more and more technical debt. And you have this picture that illustrates the Frankenstein monster. If you are not familiar, Frankenstein is a novel written in 1818 by Mary Shelley, where a scientist, Victor Frankenstein, was very passionate about creating new things, and he wanted to generate some artificial life in a laboratory, and he put things together. Yes, and he was able to create from these pieces a real human being, but it became a monster. And this is not what we would like to do. Uh, we have in Romanian an expression that comes from our literature. It's an ostrich camel. So you combine an ostrich and a camel, and you get some new creature, but this is not something that you would like. You may have some parallel with following some pattern. You have, for example, the mediator. I'm sure that most of you are familiar with the mediator. For example, you have some flights that want to land or to take off, and they are communicating through the control tower. That is the mediator. And suddenly you are receiving an urgent task to speed up some communication between flights. And in the absence of this approach that keeps the initial architecture, flights may start to talk to each other, skipping the mediator. This may solve the problem right now, but for the long term, it will generate chaos, and in 6 months, no one will be able to maintain the current architecture. You may say, okay, but these agents make us coding faster. But look at this data. There is a groundbreaking study by Matter in July 2025, so 6 months ago, that revealed some shocking truths. Most developers are expecting a speed increase, an average of 24%, and in reality, they received a decrease of 19% speed decrease. And maybe this is for the complex enterprise projects. Maybe this impacts only some experienced developers, while the junior ones are really helped by the code assistance. But the dangerous part is that the developers felt more productive. They had this illusion of productivity. Why? Because they spent a long time verifying, correcting, arguing with an AI that didn't understand the full context. And this is not the failure of AI technology. It is the failure of this improvisation that we are trying to move apart. Because without the structure, the AI can actually slowly but surely degrade the expert performance. If you are familiar with TDD and BDD, you may know that we borrow two things from here, two ideas. TDD is doing the things right, while BDD is trying to do the right thing. And this JAIG approach is trying to do the right thing, not only the things right. Okay, how to fix this? We would like to change the paradigm. In JAIG, we say that the code is just an output. Yes, it is just an output or a byproduct, because the real value, the real complexity lives in the knowledge base that may be written in some natural language. Yes. This way we define the what, the requirements, the domain model in some structured way that will be introduced as JAIG language. And this way we feed that what is our engine. And if you have a knowledge base that is complete, the code generation becomes straightforward and predictable. Predictable, this is what we would like. We have this classical engineering principle, divide and conquer, or if you prefer the Latin language, divide et impera. Many problems are of high complexity. And if you have experienced some interaction with LLMs, you know that they perform poorly when you ask something very general like, build me an e-commerce platform. It's too big. There is a big risk of them to hallucinate. They may get lost. They do not have enough details. They don't get the context. But if you ask an LLM, let's create a JPA entity for a user, then it will do a very good job. So it will be the mission of the developer to split the big problem, split by function, split by subdomain, overall apply this divide and conquer approach that is really known in computing. And we have a look here at this JAIG workflow. JAIG, that will be demonstrated immediately by Vladimir, take the specification in the format of this JAIG language and some execution plan that is defined as a directed acyclic graph, and its purpose is to produce the code. And if you look here at the right-hand side, this is some standard workflow for generating a Spring Boot microservice. This is something that you might have encountered or that you may encounter in your everyday life as a Java developer. We just don't say make the application, but we say step by step, generate the entities, then generate the DTOs, generate the service interfaces and implement them, create some controllers, and then write the test. And each step is a unit, is discrete. Each step builds on the previous one. It's like a pipeline, another classical idea in computing. Okay. But we face a mathematical challenge. If we have a 5-step pipeline, which is not a large one, you may have some reliability at the level of each step. If you have the reliability of 90% at the level of each step, which is very good for an LLM, then the total reliability of the chain is about 60% because we multiply 0.9 multiplied by 0.95 times. But we may scale up. If we have a 10-step pipeline, 0.5 multiplied with itself 10 times, so 0.9 power 10 will be approximately 0.35, which is very poor. You cannot accept, you can't run a business on a process that fails the rest of 65% of the time. And we may think about this butterfly effect of the code generation. Because if you start with a small subtle error in step 1, maybe you have missed a field in an entity. It will propagate, and by step 10, your controller may be referencing some code or methods that do not exist. Your test will hallucinate, and your whole system will collapse. That's why simple chaining is not enough. It doesn't work, and we need something more robust. Of course, we need validation. The solution is self-healing. This is something else that you might have encountered. From myself, I was listening to this idea of self-healing since I was a young student, and I was hearing about automation processes and tools of this kind. But moving now to the JAIG workflow, we don't just move to the next step blindly, but we loop and we generate the code and immediately validate it. How? It has to compile, it has to make the test pass, of course. If they fail, we don't give up, but we have the error message, which is fed back to the AI. So we have a feedback loop. You say, fix this because now we have the code and this compilation error. And we may retry with adjusted prompts. We iterate until we get a green light. If we want to detail a single step from the previously introduced workflow, this is the heart of the engine. So you take the prompt, generate the code, and then run the validators, several validators. The code has to compile. If it doesn't compile, go back and retry with the compiler error. Then self-assessment. AI will evaluate AI. It will answer to the question, did you actually fulfill the requirements? And this may be a surprise for you, but it often catches its own mistakes. And then it will run the test, because running the unit test generated in some previous step will validate things. If we answer a no in some step, then you will trigger the self-healing loop. So we allow up to 3 retries, and if still fails, then we need the human intervention. Okay. And there is another massive advantage to this architecture, and it is the cost. Because you want to be limited. You are limited by your budget. The industry is shifting. If you are using some expensive LLMs, yes, for everything, it's not economic. Yes. And there is a trend that is introduced by NVIDIA, or highlighted by NVIDIA, to use what we call small language models, SLMs. They are some smaller replicas of the LLMs, yes, but they focus on some type of expertise. They are able to know some specific task. They are specialized, and instead of using a massive LLM to write some boilerplate code, you use this SLMs, which are much more economic. Okay, we have this double win: reliability and cost. We try to be on the win-win side. So your code will be higher, will have a high reliability. You'll validate small steps rather than hoping for some miracle in one giant prompt. You may think about other approaches of this kind if you have worked with refactoring, when you always take the refactoring in small steps because it is much safer, or if you have developed your code in some incremental environment. And also, we are happy to have a lower cost. By using SLMs for the heavy lifting, you can reduce the generation by 10 to 30 times. Imagine what will be for the business, for the company, to generate the entire code base for a few cents. And let's visualize the difference. On the left-hand side, we have the improviser approach. The improviser approach, the approach with the agent that is more or less chaotic. It is like opening a Pandora's box. It will try something, but does it work? Should it retry? It may ask you what's now. While on the right-hand side, you see the JAIG approach. It has a goal, it has a pipeline, it cleans, it validates, and wants to deliver the result. So we move from the approach of asking what's now, what's next, to the JAIG knowing what's next. We have this core philosophy run-to-run variation. Yes, as developers, we treat our build tools like Maven, Gradle, or a very good example, even the Java compiler as deterministic. You compile the same code again and again and again, and you will always get the same output. For the same input, you will always get the same bytecode output. Otherwise, the world will collapse for you. But agents don't do this. There are something like stochastic engines. You cannot rely on some random number generators. You cannot build a reliable CI/CD pipeline of this kind. Yes. If your output varies, then testing will become a game of chance, and we would like to stay on the safe side, to be deterministic, and JAIG comes here to solve this by enforcing some strict controls to maximize the determinism. JAIG, let's break this acronym. It means justified AI generator. It is justified by a few things. It relies on 3 pillars. Justified by the process, because things are not improvised. They are transparent, repeatable assembly lines. Justified by the evidence, because it has to pass some verifications. Compilation, test, self-assessment. The code has to prove itself that is correct before you can even see it. And justified by origin, reproducible. The same input, the same specification, you will get the same result. We have a proverb that was used years ago. I heard, trust by verify. We trust the LLMs. They are our big helpers, our big supporters, but we have to verify. And this is some architectural approach. We separate 2 things. We separate the workflow, yes, the pipeline of prompts, and the requirements, that is the business domain. You have to put them head to head to generate a working application. You have, for example, to create a Spring Boot microservice pipeline. Yes, this is generic. And on the other side, you feed it with some pet clinic requirement. And bam, you will get this pet clinic application. Then, with the same Spring Boot microservice pipeline, you will provide from the requirement side something like a financial trading requirements. And then you get a financial trading application. The architectural standards are enforced now by the pipeline, and we do not change or reinvent them for every project. If you are familiar with the Spring framework, and I'm sure that most of you are familiar with Spring framework, you can make some comparison with how Spring separates the business code from the configuration. The application is created by putting head-to-head the code on one side, the configuration on the other side, and this will result as the fully working application. The approach of JAIG will separate the prompt pipeline, which is the technical how we do it, from the requirements, the business what do you have to do, what do you have to implement. And to make this reality, we define 2 domain-specific languages. JAIG, or JAIG language, that will formalize the what. It's some structured natural language to define business logic unambiguously, and the prompt pipeline language, or the PPL, that defines the how. It scripts what we call the orchestration steps, having as a purpose the executable business logic, and it will enforce the architectural consistency. We want not to drift, we want not to diverge. One extremely important revolutionary consequence that we would like to emphasize. Code is now just a temporary artifact. You are able to keep on regenerating it. So in the JAIG approach, the source code is not the source of truth anymore, as you could have thought previously. The source of truth is the JAIG specification plus the PPL workflow, the two things put hand to hand. If you have a new requirement or you have to fix a bug, you don't patch the code because patching is risky and it may lead to the drift. Instead, you update the specification and you regenerate. And I was saying the code becomes the temporary artifact. It is like working with Terraform. If your server drifts, you don't get in to fix it, but you kill it and you spin up a new one from the configurations. Or as an analogy, you may think about immutable things. So the code is fully regenerated. Yes, this may come with some shortcomings, of course, but this is something to be considered in the development of the future JAIG. So you may imagine some future where we have some workflow repository. You may compare them with the Maven Central Repository, of course, also used by Gradle. You don't need to reinvent the prompt sequence for something like a secure REST API. You browse the library, the central, the repository, and you pull some workflow from the repository and apply your requirements. Yes. This is reusable version architectural wisdom. Yes. And this repository, as it does not exist now, it may be created and may start to be enriched just the way Maven Central is enriched. So what to conclude about the future of the developers? What's the future of the developers? I heard many concerns about the future of the developers. The developers will remain. Our opinion is that the developers will remain, but they will have some other types of activities. They will stop being some manual executors of code. Developers will become now designers, curators of these automated pipelines. Yes. They will be the orchestrators and they will focus not on writing many pieces of code, but on solving new business challenges. No more so much boilerplate code, but you have some business, some job of conducting an orchestra. And I think this should be a real challenge and a real joy for many developers. And this is the introduction, and I would like to invite now Vladimir. It's your turn. Thank you for being here together.
Thank you,
We'll
Katalin.
follow
Thank you,
up
everyone.
now the demo.
First of all, I wanted to answer on the question from Diallo Francis. I heard that Claude Code proposed the concept of sub-agents that can perform various tasks continuously for 12 hours. And I assume that Claude Code knows how to evaluate and execute next steps. Very good question. So let me try to answer this. Claude Code is definitely amazing technology, but it solves a different problem. Claude Code with sub-agents is like a genius improviser working behind a closed door for 12 hours. It is amazing. But what we are trying to present, what we are trying to build is like industrial assembly line. Because in enterprise development, we cannot afford to wait like 12 hours to see a result that might be architecturally flawed with architectural drift. We don't know exactly. And JAIG is trying to break this bigger task to 5-minute steps with instant validation, which are reliable, which are repeatable, And if error happens at minute 10, we catch it immediately, not later. And after all, if agent runs autonomously for 12 hours, the feedback loop is 12 hours long, yes, and uh, we cannot we cannot know exactly what will be the result. Finally, yes, because agent also has the built-into loops, yes, and it is validating itself. But what is the core difference in approaches? That Claude Code is like a genius mechanic. Yes, for example, we need to repair a car or build a new car, for example. Yes, okay, you take genius mechanic, lock him in a garage for with all necessary tools for a week, yes, and he comes out with a car, yes, and it might be a masterpiece or it might be a strange hybrid with no brakes. So the result is unpredictable, and most probably, if it is genius mechanic, the result will be very good. But will it be exactly what you wanted? Most probably not. Most probably, it will be a little bit different than you expected it to be. And JAIG approach is to build a factory. Yes, we have like a conveyor belt, and at every station, like welding, painting, engine assembly, we have some robot and a quality check. And if door is welded slightly off, the line stops. And we are trying to achieve the reproducible high quality. This is so for prototyping and research, Claude Code is amazing. For having human in the loop, it is amazing. This is the best tool which exists now. Yes, but we're trying to solve a little bit different problem: the industrial scale production. And for this purpose, you need factory. Uh, the question. So
I think
what is the difference?
if you want, we can let the question for the later, and then you can
Oh,
proceed with the
okay,
demo.
okay,
Yeah.
okay. Let me. So this is some demo implementation. This is the second version of JAIG, which we recently started to work on, and this is JAIG Studio. And JAIG Studio is created to more for demonstrational purposes. Yes, because our purpose is to introduce this architecture, and our main goal is to present, to pay attention on how things could be done in different ways. But to make this more grounded, we have built this JAIG Studio. And first of all, for example, we have some specification. You can see we have uh, two parts of our two main building blocks in our JAIG Studio. One building block is the JIGGLE requirements, and another building blocks is the workflow. The In the simple case, it is just the prompt pipeline. Yes, so we have the first prompt, the second prompt. So we have some task. For example, we need to build the library management system, and there is a detailed definition. This is specification. You know, this is very widely used approach, spec driven development, very popular now. And especially when we are talking about what could be done with LLMs. So we are building the specification first of all, and this specification is in natural language in English, but actually it should be in JAIGL. What does mean JAIGL? JAIGL is just plain English, but with no ambiguity. Yes, with everything must be defined with no options, with so that we can take this JAIGL and convert it into the code. This is our purpose. So we have this specification. This is configuration. This is specification, and we have the pipeline. So, for example, we want to build this application using Spring. Just we are on the Spring conference, so we are building with the Spring, and we have some pipeline with the prompts. This is prompt number 1, for example. Yes, so please first of all create the overall. I am running it. Create the overall structure of the project, and it should follow this and that principles. Yes, so and we define just what have to be done on the very first step. This is the first step on our conveyor belt. Yes, and we can see, okay, these files have been generated. Just this is just an example, very simple one. We have application Java, we have application YAML, and the next step is the validator. This is another prompt. Yes, so it takes what have been generated before and it validates it against some criteria. And if all criteria are satisfied, result will be positive. In this case, it is not positive. We see some errors, missing Maven folder, missing package structure. So I am using for demo purposes the cheapest model for O Mini to speed things up. So in this case, the algorithm should repeat take these results, negative result, get back to the previous step and repeat it until achieving the appropriate quality. Yes, so this is the self-healing loop, which finally should produce the proper quality. Yes, only when this validator will be satisfied. But this validator is validating only the structure. There could be multiple validators. One validator which compiles the code, another validator which runs the tests, and only then, when everything is validated, we should go to the next step. This is our purpose. Not everything implemented, work in progress, but this is our purpose. And another thing to discuss is specification. How can we build the specification? To build specification, we can here you can see this specification is already prepared, but we are able to start building our new specification. Let me create the new specification. For example, I want to build library management system. Okay, this is the title, and I also enter it in the requirements. This is my purpose. This is the tool which I am going to build. And when I click create document, it is starting to build the specification. But for sure, there are many ways how this kind of system could be built. And it is asking me some questions. What types of users should the system support? Yes, for example, should I have a member? Should I can see the details. Members are the end users who borrow and return books, for example. I have librarians, and for example, I don't need admins as a separate user. Then, what core functionalities should the system include? For example, catalog management, okay, user registration we need, book borrowing we need, but we don't need, for example, reporting. This thing we don't need now. And as soon as I answer the previous questions, the new questions are generated. Yes, what primary actions should users perform? For example, borrow and return the books. No search for now, no management. What types of library materials should the system manage? Books, for example. Okay, and after all these things, we are able at any moment to click this button, generate specification. Based on our answers, system generates the specification so that we can take a look. This is the generated specification. We answer it now on very little number of the questions. And for sure, in reality, we should answer much longer. This is the very long, like, interview made by AI. And finally, okay, this is the first step. This is the first level of specification, and we can manually edit this file. And this is already JAIG. Yes, JAIG specification, because it is not just plain English. It is English where we resolved ambiguities, and we are able to click like continue clarification. Okay, stage 2. We're continuing, and on the next stage, we again are answered with the questions. So this is what types of library materials should the system manage? Books, no magazines, for example, no ebooks. Which user roles should the system support? Member and librarian, and so on and so on. So after all, this the system AI in our case gets the more holistic, the more complete vision of what we're going to build. So I can continue these steps, and at some moments I can do some like cutoff. Yes, I can generate specification with more details, which will be more detailed than previous stage of the specification, and at some moment I may stop. So this is the result, maybe not complete, but the really complete result requires session of maybe 50 or 100 questions and answers. And finally, when we have this complete vision of the system, we are able to continue. For example, here we have specification analysis. Yes, for example, we take this specification, and for example, this is the prepared prompt. Generate actors of the system. Yes, actually, actors we already have been defined, librarian and member. But here we are able to generate the separate document. Like, okay, here we're asking, please generate a separate document, and this is the document generated, librarian and member. We have two types of the actors in our system. It can be librarian or member. Then we can generate, for example, user stories. User stories is not something which can be directly taken from the specification. So we have it separately, and we can run it, and it is generating the user stories. Yes. So generating. Then we can generate glossary, and for example, so this is the user stories. Here it is generated. Yes. Book reservations. This is what could be done with the system. Yes. The user story. What should be done? This is not something directly explained in the specification, but what are the basically what are the user interface, or what is API of the future system? What could be done? User authentication, manual book management. Yes, user story. What should be done? Search functionality, catalog access, so on and so on. And okay, I will also demonstrate use case diagram. For example, this is okay. Let me run it. Use case diagram. So here we've got use case diagram generated in plant UML, and I am able to open it, preview, and okay, we have two users, librarian and member, and the capabilities of each of these users. So our idea is that all this pipeline is predefined. This is the next step after we generated the specification. Yes, we need to go through the analysis. Yes, and we generate actors. These are various architectural documents. So the first step is that we generate specification. Second step, we do the analysis of this specification. And third step is we generate the code using different workflows. And as Katalin said, we may have the library of these workflows. Yes, so we can take one or another workflow. For example, workflow of Java applications, Java and Spring application, workflow of Java Enterprise Edition application, workflow of VertX application, and so on, Node.js application, Python application. So the same specification could be applied to different workflows, and the purpose is that the workflow will produce completely usable and reliable code. Yes, so this is our factory, this is our conveyor belt, which takes the specification and builds the workflow. And one of the main ideas behind it, that we do not make patching. Instead, we are regenerating. For example, if we made some changes in the specification, we take it and regenerate the product from the very beginning to the very end. And the last thing, to demonstrate how we can build something more complicated, because you see here we have like pipeline flow where we have just multiple prompts, where one prompt is preceding another prompt. Yes, but it works for the simple cases. Yes. Because if we need something more complicated, we need some more complicated logic of orchestrator, not just simple sequence of execution. Yes, for simple cases, simple sequence works. Execute this, then execute that. But in more complicated cases, we can create, this is the builder of the uh, workflow, and we're using PPL. PPL is prompt pipeline language. Yes. So in a simple case, prompt pipeline language is a simple sequence of the prompts. In more complicated cases, it could be something more difficult, more complicated. Write an article, for example. Write an article. This is my request. What should be done? For sure, I can take something ready to use from the library. I should be able to take, because our purpose is to create some kind of workflow library, which is something similar to Maven. Yes. So, for example, if you need some library to be used in your program, you go to Maven and download it. In the same way, you can download the workflow. But also, AI could be used for generating the workflow. For example, workflow write article. It is generated by AI completely. Read specification. Use prompt outline to produce outline. First of all, we are producing the outline. Split outline into sections. And for each section in sections, use prompt generate paragraph with section to produce paragraph. So we take the outline and generate each paragraph one by one. And also we are running grammar check for every paragraph. And then we join paragraphs into the article and save this article as article MD. And okay, this is, you see, this is plain English to make it easier to edit, to understand. But on the next step, it could be compiled into JavaScript, and JavaScript is behind. Yes, JavaScript is something what is actually executed, and PPL is what we are seeing, what we are editing. And in addition to, so this is JavaScript generated. Yes. So what it takes, it is reading specification, it is running prompts and passing some parameters to the prompts. Okay, I will review. Write article, create workflow, and you can see this new workflow is generated. This is the description in PPL, and then we have these prompts, outline prompt to generate an article, generate paragraph, grammar check, and here this PPL is something more complicated and more complete, more flexible than a simple sequence of the prompts. So it is theoretically very powerful thing, because okay, basically we can uh, um, put any logic, yes, the loops, the ifs, and so on in these kind of workflows. So to summarize, we have separated the requirements from the prompt pipelines or workflows. And when we make the changes in the specification in JAIG, yes, specification without ambiguities in plain English language. We are just rerunning workflow, and for the same specification we can apply different workflows depending on what we want to achieve, and the same workflows also for sure are reusable with different specifications. Yes, now this workflow is writing article about libraries. Next time the same workflow could be used to write article about quantum mechanics. Okay, that's it from my side.
So, thank you very much for your presentation, Vladimir and Katalin. I think it was a very nice way to explain how it can be, let's say, this way of working with AI could be thought in another way based on some rules, and also how it's possible to describe the process in more, let's say, comfortable way where you can clearly define the rules that you want to follow. Even though I think that we have some questions in the chat, so I think we can start with some of the questions that we receive. For example, this one, I don't know, for example, what you can
What is
tell
the
us.
difference between JAIG, PPL, and the skills? Yes. So skills are like tools, and PPL and JAIG are like plans that control these tools. Yes, because skills are like atomic capabilities. What exactly have to be done right now? JAIG is specification, what should be done, and PPL is the orchestration. Yes. So theoretically, I have an idea that we can uh, apply the same architecture and build it into Claude code. I haven't tried yet because skills are quite new approach and technology. But theoretically, we can create a skill which will be serving like an orchestrator. It will not have the same reliability as programming language, because now as the workflow we're using JavaScript, but at least especially for Claude code, which is very reliable, maybe its reliability will be enough. So we may create a skill which will be serving as a orchestrator, and skills which will be serving as the steps in this workflow, as separate steps. So we have the plan to implement it, to try to implement it based on the skills, but we presented architecture, not the tool.
So it can be summarized so something like this, no? That the JAIG is the receipt and the tool skill is
Yes,
the
yes,
ingredient molex.
yes.
Please remember about one of the slides. I'm not sure. So we said we put head to head two things, and we made the analogy with the Spring approach that was putting head to head the code and the configuration. So we need two things to be put head to head, as here, yes, okay, JAIG is the recipe and the tool skill is the ingredient, if you want to express it like this. But the whole application is the result of putting head to head two things in Spring or in JAIG.
Cool. So there are some interesting comments in the chat, and some of them they feel that they look like, I don't know if you know Spring Initializer, but it looks like the Spring Initializer improved, let's say, and that's why
AI powered Spring Initializer.
yeah, looks like it's perfect starting point. I totally agree. Like it's like you can start with something more than just pure libraries, etc. So yeah, and we have another question here about how it's going to be evolved, no? How it's going to be regenerated. So every time that you have some
So our
update.
purpose, yes, our idea is that this generation is getting cheaper over time, and especially when we split our bigger task into very small tasks, we can use cheaper models. And we want to completely get rid of patching, because patching leads to architectural drift and many problems, and replace the patching with regeneration. For sure, regenerating the complete project is impossible, especially if it is a big project. But if we split the project into very simple, very small and loosely coupled models, regeneration seems realistic.
Let me add here, please, because we discussed together, Vladimir and I, how to approach here. Yes. If you are familiar with the React approach, where the UI is represented internally as a tree, the web applications also heavily think about immutability. Yes. And regenerating the whole tree is a heavy operation. We talk here about some DOM reconciliation, it is called. But if you analyze the tree and you find out that you need to regenerate from this node downwards and from this word downwards, this will simplify things. But this is at the level of our discussions now and not yet into the implementation. Immutability is a great thing. I mentioned immutability while I was presenting, but of course it may come at some costs in programming if you want to make some analogies.
Mhm.
So the idea is that if specification have changed partially, we can find exact places which should be regenerated.
So from that node downwards, if you
To avoid
if it
the
helps,
complete
right?
regeneration. But anyway, it will be not patching, it will be partial regeneration.
Okay, I think the question is, let's say, answered. And I have another one, which is more or less, well, I think it's related in the terms of how we address instead of improvements, let's say, in case of bugs. No, it's very similar that we forgot something.
Regeneration, yes. So the
Regeneration.
idea is that we never fix bugs directly. So instead of it, having bug means that something wrong in the workflow. And we're changing workflow, and it means that next time when we will apply the same workflow for another task, this bug will not raise. Yes. So we are creating the repeatable, reliable workflows as the factory, as the production.
So
Okay.
you may say that if the workflow has some issue and you regenerate it with the same workflow, you will get the same bug. You have to fix the workflow and to regenerate. And if you translate the same workflow for some other application, most likely you will have the same bug. If you fix the workflow, your application will be fixed. I think such a bug fixing will be very interesting to be approached in the context of what I was discussing about the trees, about regenerating some part, but still regenerating and not patching.
Yes, so this behaves like in DevOps. Yes, if you find some problem with your configuration, you're changing the configuration and reapplying everything. Yes, you're not patching anything. You're recreating the server. You have changed something on the Docker side, for example, or on Kubernetes side, and regenerate. And in our concept, code is the same disposable artifact, temporary created. Yes, so it is not the source of truth anymore. Source of truth is in the workflow and in the specification, and code is just the result of their combination.
If you would like, also for the Java developers, if you would like to make some analogy, think about the code now, not as you are accustomed, but as the .class file, as the compiled version. Yes, they will be regenerated.
Mhm.
Yes. So it's just an artifact and not the source of truth. And you
Yeah.
can make this analogy. A jar file.
Good idea. Yeah. So JAIG is like a compiler, AI compiler of new era. Yes.
I was saying we have to try to move to this deterministic of the compiler, because if our compilers are not deterministic, our whole world will break. Will not be here. We'll do something else. If we lived in an undeterministic world, while using the compilers.
Yes, exactly. And
But
instead
we try
instead of class files, we produce Java files.
we try to move closer to this
Yeah, to
determinism.
the human specification, no. That's my, and this is my, the question that I have is that now I can see that we are more let's say close to the English speaking, no, that as we understand the definition of something as I understand as a user, we will be possible to just basically by writing my specification as a user, saying this is what the thing that I want to do, and then pass it to the JAIG, and then the work can be applied in that regard. No, in the future I'm thinking no too far away, but that's more or less the idea, to specify each requirement and an analysis from the overall high level perspective, right?
Yeah.
Somebody asked here if the human intervention is no longer needed. Oh, it is needed, because you are not just like an automatic pilot. Yes, we say, bring me to Santiago de Chile. I don't know, and I have no other thing, because that will be like, it's too general, and the LLM will start to hallucinate. But we are the guides. The developer will be the guide that will have to make sure you are on the right track, and of course you follow some pipeline. Yes, you are not diverging, or not diverging with, or drifting, because we use this term of drift.
Mhm. Another question that I have is that related to the LLMs that you mentioned, that probably is not so economic to run big models, etc. So I guess these ideas that the short LLMs are more suitable, because they are smaller, they are focused on some specifications, some concrete things, and also to write code in a specific way that we expect. I guess this is something that you already designed it in that purpose, for this perspective, let's say. But it is possible to let's say set up some validation rules that for example, as a team, I need something different from other stuff, or I have some strict rules on my company, whatever.
Yes, and from the economic perspective, code generation is quite expensive, and I have heard recently that, for example, Claude Code, if you have the subscription, is about 20 times cheaper than if you are using it via API, and it makes, to be honest, it makes tools like this JAIG Studio quite useless. Not useless, but too expensive. Because we are needed. We are forced by producers to use tools like Claude Code, by producers of LLMs, or Codex by OpenAI. So what I'm thinking, it doesn't cancel the ideas behind JAIG, but I'm thinking that we need to try to implement the same architecture inside Claude Code to make it more reliable and more predictable, but implemented with skills, actually. I think it will be our next step.
Nice. So I think was it, because we don't have more questions. So I think we answered all of them. What I can say is basically thank you for being here, Vladimir, Katalin. It was a pleasure to be hosting your session, and I hope all the attendees receive really nice content. So before ending, if you can share the link of the project, please do so in the
Yes.
chat, because then the people can go and check it out, and then, I don't know, probably contribute somehow. If it's open source, project, right?
Yes, but I don't know. Just one moment.
If not, we can always post it later on the YouTube channel and in the video as a comment. So
We're having trouble connecting to YouTube account. I don't know. I can just show it. Let me just one moment. I will share screen, and that's it. This is JAIG Web on the GitHub, so you can find it github.com/sonkin/JAIG Web. And okay, here you can find the project which I demonstrated. But this is mostly for demo purposes. I would say yes. So the first thing we wanted to demonstrate is not this tool, but the idea, the architecture, and the future of code generation.
Cool.
As seen from our side. Maybe other people have other views.
Yeah. Okay, so thank you very much once again, and hope to see you soon, everybody. See you in the next one.
Thank you.
Bye-bye.
Thank you, everyone. Bye-bye.